Hi, in this video I'm going to make a 3D scan of this simple object and reverse it in CAD, but this time I will use FreeCAD, which is free to use CAD software, and show you how I reverse it from the point cloud. Because sometimes when you make a 3D scan you won't get 100% because there is a deep gap or a crevice, and the geometry of the object itself is blocking the projection of the scanner. If you learn how to reverse the scan object in CAD, you will get a complete model, and also when you use it for 3D printing, the 3D model that's generated in CAD will get you a better 3D printing result. And sometimes the object that you are going to scan has defects or a damage. To get a nice clean model, the best way is to reverse in CAD. I will use the Laptop Pro for this scan. I will choose 0.15 for the resolution. I choose parallel lines. You need to increase the brightness for the orange color and start the scan. Let's clean up. 0.15. Okay, as you can see that there is a defective on the surface from the damage of the object, and in some corner it has a blind spot, and this is when the reversing in CAD is a good solution to get a complete model. The best practice for reversing is using the point cloud, because you will be able to clearly see the wall of the surface, and you can trace it with a higher precision than you do with the mesh, especially in the FreeCAD. And the bottom side of this object is just a flat plane, so it's not necessary for make a second scan. This will be enough for reversing. Okay, next step is to export this point cloud. I will export this as the ASC format, and then I will align the point cloud to the XY plane and change the origin point by using the CloudCompare. Okay, one thing to note for MAF3 user, if you want to export the point cloud for using in FreeCAD, you can do that by exporting your scan in XYZ format. This is the point cloud format for MAF3. Okay, this is CloudCompare. I put download link in the description. It's a freeware. It's used for processing point cloud. It can do a lot of things. Okay, if you are using MAF3, your export files will be in XYZ format. What you have to do is just drag and drop it into CloudCompare like this. But one thing to note that you need to skip the first line. Here in the bottom of the menu, you see skip line. They put some the company names into the first line, so you need to skip it. If you don't do this, you won't be able to import it. So I skip the first line. The point cloud will show up here. Okay, here's a mesh from the MAF3, which is about 493,000 points. Okay, let's move back to Clarity Scan. For Clarity Scan, we export in ASC format, which is ASCII format. Drag and drop. You don't have to skip any line. For the Clarity Scan, just click apply and you get your point cloud here. My CloudCompare color probably different from yours because I like darker background for using with a bright point cloud, so it give me a high contrast and easier to work with. To do this, you go to display setting and click on the color and click on the background here and choose the black color, and you will get this same black color as the background. Okay, next if I click on the top view, you see that the scan data is not aligned to the XY plane. See here, this is the front view. It's not aligned. So to start reversing, it's quite necessary to align your object to the XY plane. So you need to pick one of the flat plane and make it align to the XY plane. This is the reason that I import the point cloud into the CloudCompare, because it has this function. You see the little triangle on the left here, pick 3 points to make a cloud mesh level. You can align mesh and point cloud with the CloudCompare. Click on your point cloud, there will be a bounding box. Come up and click on 3 points. So I'm going to look for a flat plane and I will choose this one. You only need 3 points to create a plane. So now this plane is aligned to the XY plane. If I click on the front view, see here, it's now aligned to the XY plane. This will give you much easier to work when you start reversing. Next, if you look at the property box, you see shift box center. That's the coordinates of the current object. It's a bit away from origin point. I will move this object to the origin point. It doesn't have to be perfectly at the origin, just approximate. We will do this later in the FreeCAD. So what I do, I click here, this button, I click on Advanced tab. I move X-axis to the right about 32 millimeter. See, shift box center, X is too much to the left, 31.8. So I move it to the right, 31.8, and let's say 32. Okay, I move it to the right, so I click forward. Now the star move forward to the right, and for the Y is 6.8. I move it down, I click backward, and for the Z I click on check mark. I want this point to be at the bottom of the Z axis, so I click here and check for the coordinates because we didn't scan the bottom side, so I choose the lowest point here. Now it's you see here, Z is minus 201, so it's too low, so I move it up about 201 millimeter. So what I do is I do the same thing. I move this up in the Z direction for 201.3 forward. Click check mark. Now it's moved up. I'm going to click here. See this point. Let me click on the coordinate checking. This point will be 0.02 millimeter from the origin point. Now this point cloud is ready for reversing with a FreeCAD. Okay, next you need to export this as the PLY format. Click on PLY mesh. Okay, this is FreeCAD 1.0, probably the first version. You come to this interface. I click on parametric part to start a new project, and you come into this window. They have a different user interface. If you click here, there's a lot of user interface. It can also do a surface modeling. The main interface that we are going to use today is part design. There's a part interface which has a very similar name. It is different. We are going to concentrate on part design. Part design is when you create a 3D model by using a sketch. So this is the same process that used in Autodesk Inventor and SolidWorks, and some other major CAD software also create a CAD model from a sketch. Okay, first step, I'm going to import the point cloud. I will leave the link in the description for the original 3D scan files so that you can practice this tutorial. I'm going to click on File and Import. FreeCAD can import a lot of file type, and for the point clouds, it can import ASC, PCD, PLY, E57. I have tried with ASC, doesn't work, but for the PLY it works, so I will just use the PLY for now. I click on open. We have our 3D scan files here. I'm going to click on the model tab, click on the point cloud. I'm going to change the color here. I'm going to change it to a bright green color. If you import the mesh, you won't be able to see the wall. Now we can see a very nice thin wall for doing tracing. I don't like the background color, so I'm going to change the background color. I'm click on display color, and I'm gonna change it to black color. No, it's too black. So if you look to the right, it's all flat to the XY plane. Our point cloud is already aligned to the XY plane, but what is not aligned is to the center point. See here, it's not aligned to center point, so I'm going to move it. How I do this? I'm going to create a sketch. Click on here, and I'm gonna choose XY plane. Click on the XY plane. Okay. Now you can see that our point cloud is not in the center. It should be in the center because I want to do a mirror function. So I'm going to draw a circle using a 3-point circle. So I'm going to draw a circle here. 1, 2, and 3. And next I'm going to measure the diameter of the circle. It's 36.12. So I'm going to delete this one. Next I'm going to create a new circle using the center and radius. So I'm gonna type in 36.02, but this circle is in the center. Close the sketch, click on the point cloud, right click, placement. Now I'm going to move the point cloud to the center. So I'm going to move it down, you see here. So I'm gonna move it to a y direction, -1, 0.2, 0.3, 0.4. Okay, now it's touching. See here, every corner of the star is touching the circle, so this part is in the center. And next I'm going to click on apply. Next I'm going to do a rotation. Click on the same sketch, create a new line. This line will be a horizontal line, so that I'm going to rotate it so that the left and the right arm of the star is level. Place the horizontal constraint onto this line. Next I'm going to do the same thing. Placement. I'm going to rotate the star on the z-axis. Z-axis X, Y, and Z. Z is has a 1 number there, so it's active. I'm going to rotate it 0.2 minus, okay, and 0.5, 1 degrees, 2 degrees. I think it's in the center. I'm gonna move it to the left just a bit. So x-axis minus 0.1. Okay, all right, now look like the star is aligned. Click on apply. Okay, now we have an aligned point cloud. The center of the cylinder here is also in the center of the origin. I'm going to hide the sketch because we don't need to use it anymore. I'm going to create a new sketch in the XY plane. Okay, it's a new sketch. Before that, I think the point cloud is too big. And click here. See, point size is 2.0. I'm going to change it to 1. Okay, now the point cloud is small and thin. I like that. Okay, click on the sketch that we just made. It's in the origin point, XY plane. I'm going to trace a line. So first, I'm going to create a mirror axis. I draw only half of the star. I start by tracing with the arc. I use 3-point arcs. 1 and 2 and 3. Okay, this is our first line, and the second line will be here. 1, 2, and 3. Okay, I'm going to make a next arc line. Okay, next line. I'm not sure if you can see this, but I can clearly see everything. Arc, line. Okay, arc. It's the final one. Arc and line. Next I'm gonna trim half of the arc because we don't need it. Click on this command, trim and trim. Okay, let me turn off the point cloud. Next I'm going to mirror all the lines on the left to the right. I do this by selecting all the line. Click on mirror. This one is mirror. Click on the line. Okay, now it's mirror. And next I'm gonna delete the line that I use for the center. Now we have finished our first sketch. Click on close. If I turn on the point cloud. Okay, next I'm going to extrude it. And to do that, click on the sketch that we just made. Click on here, path. The command name is path. Click on path. Next you are going to change the height. See here, you're going to change it until it touches the top of the point cloud. I would say 7.5. Okay, 7.5 will be the number. Let's try 7.4. Okay, 7.4, 7.45. Okay, 7.45 will be the actual dimension of this object. I'm going to click on OK. So the object is solid. You can't see the point cloud inside. What I do is I click on path. Path is the object that we just created. I click on right click on appearance, and then I will increase the transparency to 40%. Okay, now you can see point clouds inside of the solid. Close. See here. This is that's why I always recommend you to do a reverse with the point cloud, because if you do this with the mesh, you won't be able to see anything. It looks like an X-ray. And number two is that when you mesh the 3D scan, the software will apply smoothness, and that is when you lost the accuracy. Okay, next going to cut a pocket inside here and create a wall. So I'm going to create a sketch on the top here. I click on the this plane first because I want to create a sketch on this plane, and then I click on the sketch command. So now we have a sketch. Click on the top view, right? We have a sketch. I'm going to go back to the model and create a visibility for the first sketch that we just made, because I'm going to copy the first sketch to this one here, to the new sketch. So what I do is that I'm going to click on this command, create carbon copy. So create carbon copy of this sketch. Okay, the first sketch is now on the top here, and next I'm going to offset the wall thickness. I need to select all of the line that I want to offset. So I hold the control key, I think. I forgot to tell you that I'm new to FreeCAD. I downloaded this FreeCAD yesterday and I never used it before, but I've been using Autodesk Inventor for 25 years. So it's similar. Offset. Okay, it's work. See here. You need to click on all the lines and click on offset. And for FreeCAD, you need to input the offset number here, and you can't change it. I think it's 2.8 minus 2.8. Okay, and I'm going to use the this offset line to cut the pocket. To do that, you need to delete this line, the first line that you just copy. You need to delete it. I don't know why I have to do this, but in the Autodesk Inventor I don't have to, because when you do extrude cut, you can't choose which sketch to cut with the FreeCAD, so it can contain only one sketch. So this will be the closed loop sketch for cutting. Okay, I'm going to click on close. Before we do anything further, let's save it. I'm going to cut this sketch down to the bottom here. What I need to do is I click on the sketch, click on here. The yellow one is the adding of the solid. The blue one is the cutting. So they separate the tools. So I'm going to click on pocket, right? See here, it's it cut to 5 millimeter, which is too deep. You see the line here, that's the point cloud reference. So I'm gonna type in 4. All right, look like 4 millimeter would be the number that for this pocket cutting. I'm going to click on OK. All right, so we have a pocket cut. Okay, next I'm going to create this shaft here. This shaft, if you look here from the side, it's taper and it's round, and the top is round with a 2 radius, first radius and the second radius. So I'm gonna make a sketch and revolve it, because this cylinder is in the center of the origin point, so it will be easy to do. So I'm going to create a new sketch on the XZ plane here, right? And then you can do a sketch cutting. This bond here, it will make a section cutting of the sketch. And next I'm going to project. You can use this button here. It will project the plane onto the sketch. Okay, alright. So see the line here. It's quite difficult to click, probably a bug of the software, but it works finally. And this magenta line here is a project line. And next I'm going to create vertical line from and this line I will trim it. I will trim using this command. Okay, I trim it. Now we have a rotation axis. And next I'm going to create an arc. I should probably do this. Oh, the point cloud is okay. If you look here, your point cloud is also section. When you section the sketch, this is a very good feature, so you don't have to do it manually, right? So I click on 3 points. 1, 2, 3. 1, 2, 3. I'm going to create a line. I think this one is taper, a little bit of the taper. I'm gonna move it here, right? And then I'm going to trim it, right? I'm going to create a line to close the loop here, this line to this line. Okay, now the loop is closed. I forgot to trim this line, so I'm going to trim it. Okay, now the line is trimmed. Close it. So now the Y is all closed. Click on revolve, alright? So if the line is closed, it will start to revolve. Yeah, let's try half revolve. Okay, this is half revolve. So let's try 360. Okay, full revolution. Click on OK. Now it's fully revolved. Okay, next I'm going to do a fillet, but I'm going to print this in this direction. So I think I'm going to use chamfer instead of the fillet because it will look better. To do the chamfer, I click here. Chamfer 0.6. Okay. 0.6. Okay. So a chamfer with the FreeCAD, it doesn't do very well. So with the FreeCAD, it's a bit difficult to do a chamfer when you have a mixed curve and straight line. So there's still bugs that need to iron out. So let's turn on the point clouds. You can export this for 3D printing. You need to select the model, which is chamfer number 7. Click on File, Export, and you can click on STL, right? And then I'm going to click on Save. There is no other setting, so I'm going to check the quality of the STL files that I just export for 3D printing. Creative Print. And this is the files that we made with the FreeCAD. If you look closely, you can see that it doesn't have high resolution. With the Autodesk Inventor, I can choose the export resolution of the STL files. But with the FreeCAD, I think the resolution is not high. It should be good enough for FDM printing. Okay, let's slice it. Okay, let's send it for printing and check the print quality. Okay, here's from the 3D printer, K1 Max. I think the printing looks very nice. If you was in CAD, you usually get a better surface printing than the direct printing from the 3D scanner. It's smoother and the edge is sharper. Exactly the same size. It's perfect cloning using a FreeCAD. I didn't expect this FreeCAD to work this well. I never tried before until yesterday. There's some bugs and issue with the chamfer. I think they could be an improvement in the future, but you can definitely reverse more complex surface with FreeCAD, but it would take longer time than Autodesk Inventor or SolidWorks. But as I said before, it's free. So in my next video, I will try to make a tutorial for a little bit more complex object with FreeCAD. Okay, thanks you guys for watching. I'll see you in the next video.